Welcome to another episode of the Part 145 EASA training from Phoenix Way Academy. Hi, I'm Sarah.
Hi, and I'm Sam.
Well, in this deep dive, we're going to continue our look at 145.A.42 components. Last time, we started exploring just how crucial components are in aircraft maintenance. And today, we're really going to unpack the details of what makes a component airworthy, and just as importantly, what makes it unacceptable. It's such a foundational area for anyone in maintenance, ensuring safety right from the start.
Absolutely. And what's key here is that the regulations aren't just about saying this is good. They're very clear about what is not acceptable and, crucially, why. Understanding these classifications, these acceptance procedures, well, it's vital for maintaining the integrity and safety of every flight. We're really focusing on the practical side of these rules for you, the learner.
Okay, let's dive right in then. Our first big topic comes from AMC 145.A.42 subsection A, clause 3. This focuses specifically on unsalvageable components, basically the stuff that simply cannot be used on an aircraft. Full stop.
Right. This is critical from the get-go. The rule states, the following types of components should typically be classified as unsalvageable. It's about immediately identifying and isolating things that pose a direct safety risk. So, first up, we have Clause A components with non-repairable defects, whether visible or not to the naked eye. This is really fundamental. We could be talking about tiny microscopic damage, maybe internal fatigue, something you might only find with non-destructive testing, like a tiny crack inside a landing gear part. If you can't safely repair it back to its original design spec, it's unsalvageable. Simple as that.
So even if it looks perfectly fine on the outside, if it can't be fully repaired to guarantee its integrity, it's out.
Exactly. No compromises there. Then we have Clause B, components that do not meet design specifications and cannot be brought into conformity with such specifications. This covers parts that maybe weren't manufactured correctly in the first place, or perhaps they were damaged in a way that permanently changes them. Think about a bolt made just slightly too short, or maybe the thread pitch is wrong. Even if it's brand new, if it can't be fixed to meet the exact specification for where it's supposed to go, it's unsalvageable.
Okay. Makes sense. It has to be exactly right.
Moving on to Clause C, components subjected to unacceptable modification or rework that is irreversible. So, if someone performs an unauthorized modification, or maybe just does a really bad job on some rework, and you can't undo it or fix it properly, that component is now potentially dangerous and permanently compromised. A classic example. Drilling an extra hole somewhere. It shouldn't be on a frame component. If that weakens the structure irreversibly, the part's done for.
Irreversible being the key word there.
Absolutely. Then Clause D, parts with mandatory life limitations that have reached or exceeded these limitations, or have missing or incomplete records. This one's crucial. Lots of aircraft parts have a fixed operational life. Think fatigue, wear and tear. If a part goes beyond that life limit, even by 1 hour, or if its records are lost or incomplete so you can't prove its history, it's a major safety risk, like an engine turbine blade with a 10,000-hour limit. If it hits 10,001 or the logbook's gone, it's unsalvageable. Traceability is everything here.
Right. You lose the history, you lose the part.
Pretty much. Next, Clause. Components whose airworthy condition cannot be restored due to exposure to extreme forces, heat, or adverse environmental conditions. Karis, think about events like a really hard landing, or a fire, or maybe just long-term exposure to a corrosive environment, like salty air. These things can damage a component's basic material properties or structure in ways that just can't be properly fixed. You might have a part from an aircraft that was in a fire. It might look okay on the surface, but the heat could have changed the metal's internal structure, making it totally unsafe to use again.
So hidden damage from extreme events is a definite no-go.
Definitely. Then there's Clause F, components for which conformity with an applicable airworthiness directive cannot be accomplished. Airworthiness directives, ADs, they're mandatory actions to fix known unsafe conditions. If an AD applies to a certain component, maybe you're requiring a specific inspection or modification, and you cannot perform that action, or the part fails the required inspection and can't be repaired according to the AD, well, that component can't be used. It's unsalvageable.
So compliance with mandatory safety actions is non-negotiable.
Correct. And finally, Clause G, components for which maintenance records and/or traceability to the manufacturer cannot be retrieved. This loops back to that traceability point. You absolutely need a clear history for every part, right from the manufacturer through every maintenance action, if those records are missing. If you find a critical part, say, lying around with no paperwork, no idea where it came from or what's been done to it, even if it looks brand new, without that traceable history, You just can't verify its condition. It has to be classified as unsalvageable.
Wow, okay. So the big takeaway here for unsalvageable components, it really boils down to, if there's any doubt at all,
Yeah.
about its physical integrity, its history, its conformity to design, or its compliance status. It's out. No questions asked. It's a very strict zero-tolerance approach.
Exactly. And for very good reason. Safety always comes first.
That was a really clear breakdown of what we can't use. So now let's switch gears and look at AMC1, 145.A.42. Subsection A, Clause 4. This deals with standard parts. And this is interesting because they have a slightly different route to acceptance, right?
That's right. This section identifies a specific category, these really common parts used everywhere in aircraft building and maintenance. And because they're standardized, their acceptance process is somewhat simplified. It builds on that inherent trust in the standard itself. So Clause A gives us the definition. It says, standard parts are parts that are manufactured in complete compliance with an established industry, agency, competent authority, or other government specification. And that specification includes everything: design, manufacturing, testing, acceptance criteria, even how it's identified. The spec has to be published so anyone can make the part to that exact standard. It lists examples like NAS, AN, SAE standards, the common ones, ANSI, EN specifications, and so on. Basically, these are like off-the-shelf items, made to universally recognized published standards. Think of a standard bolt or nut made to a NAS spec. Any manufacturer making that NAS bolt makes an identical, interchangeable part.
Got it. So they're like the universal building blocks. Because everyone agrees on the exact recipe, things get simpler.
Precisely. But there's still paperwork involved. Clause B explains the designation and documentation. It says the type certificate holder, or whoever declared the design compliance, can issue a standard parts manual, or they might just reference the specific standard in the parts catalog. And the documentation that comes with the standard parts needs to clearly relate to those specific parts. It needs a conformity statement, and it has to list both the manufacturer and the supplier source. And crucially, if there are special conditions like storage life or specific handling needs, that has to be on the documentation or the packaging too.
Okay, so still traceable, still documented, just maybe not with the same level of individual certificate.
Exactly. Which leads us to the key point in Clause C. An EASA Form 1 or equivalent is not normally issued, and therefore none should be expected. Unlike, say, a complex engine component that needs its own individual EASA Form 1 release certificate. Standard parts prove their conformity through adherence to that published specification and the accompanying batch documentation.
Right. And that must make a huge difference in terms of paperwork for these really common high-volume items. It simplifies the supply chain quite a bit.
It absolutely does. It's built on the reliability of those established standards.
Okay, now digging just a little deeper, there's AMC2, 145.A.42A4. This adds a specific clarification, particularly for sailplanes.
Yes, and this is a great example of how regulations adapt to different types of aircraft and their specific operational risks. It specifies that for sailplanes and powered sailplanes, certain non-required instruments or equipment can sometimes be treated as standard parts. These are items certified under a specific part of CS22. If their failure wouldn't cause a safety hazard. It clarifies required means required by the Airworthiness Code, Air Ops rules, or air traffic management like a transponder. Examples of things that might be standard parts on a sailplane include electrical variometers, maybe simple bank indicators, final glide calculators, things like that. And this is critical equipment that is required by the Airworthiness Code, like oxygen equipment, must be approved properly, usually to an ETSO standard or equivalent. It's definitely not considered a standard part.
Ah, I see. So it's risk-based. If it's not essential for basic safe flight in that specific context, and its failure isn't hazardous, it might get treated as a standard part. But safety-critical stuff always needs the higher level of approval.
Exactly. It's pragmatic for that specific type of flying. So to sum up standard parts, think reliable, pre-approved by virtue of meeting a published standard, streamlines maintenance, and crucially, you typically don't expect an EASA Form 1 for them.
Okay, clear. Now, moving on from components and standard parts, let's look at AMC1, 145.A.42, subsection A, clause 5. This section focuses on material.
Right. Another important distinction, this covers the stuff used during maintenance rather than the components being installed. And the acceptance criteria are different again. Clause A defines consumable material. It says this is any material which is only used once. Think lubricants, cements, paints, sealants, stuff you use up in the process, like the sealant around a window or grease for a bearing.
Okay, the single-use item.
And Clause B defines raw material. This is any material that requires further work to make it into a component part of the aircraft. So sheets of metal, rolls of fabric, lengths of plastic, the basic stuff you might fabricate a repair patch from, for example.
The building blocks for making parts, essentially.
Exactly. Now, Clause C covers acceptance. Material both raw and consumable should only be accepted when satisfied, that is, to the required specification. And how do you get satisfied? Well, the material and or its packaging should be marked with the applicable specification and, where appropriate, the batch number. So again, it's about verifying it meets the standard using the labeling and packaging. Batch numbers are key for traceability here, too.
Specification and batch marking, crucial for both types.
And Clause D covers the documentation. Similar to standard parts, this documentation should clearly relate to the particular material and contain a conformity statement, plus both the manufacturing and supplier source. And again, some materials are subject to special conditions, such as storage conditions or life limitations, etc., and this should be included. So that certificate needs to confirm the spec, the source, and any special handling needed, like keeping that aircraft fabric in the right environment.
Got it. Documentation is still key.
Absolutely. And finally, just like standard parts, Clause E states, an EASA Form 1 or equivalent should not be issued for such materials, and therefore none should be expected. Their acceptance relies on meeting the specification detailed in the design data, like the aircraft's maintenance manual, and having the right conformity documents and batch traceability, not an individual Form 1.
Okay, so for materials consumable or raw, the acceptance hinges on meeting the required spec, correct marking, and proper documentation confirming conformity and source. No Form 1 expected.
That's the essence of it. Specification and traceability are paramount.
Right. Now, there's a piece of guidance material, GM 145.A.42B, which adds an important restriction on using certain components.
Yes. This adds another layer, specifically for higher risk operations. It's a general guidance point, but carries weight. It states, use components maintained by a CAO, appropriately approved for component maintenance, and released on an EASA Form 1 cannot be installed on complex motor-powered aircraft or aircraft used by an air carrier licensed in accordance with Regulation, EC, No. 1008-2008.
Okay, unpack that. So even if a used part was properly overhauled by an approved shop and has a valid EASA Form 1,
Correct.
you still can't install it on certain types of aircraft, like complex ones or airline aircraft.
That's exactly right. For those categories, complex motor-powered aircraft and licensed air carriers, there's generally a prohibition on installing used components, even if they appear fully certified. It's about an extra margin of safety for those operations. Think about our earlier example. A prop blade overhauled from a small plane, even with a Form 1, can't go onto a big commercial jetliner.
Why that extra restriction, though? Is it just the higher stakes involved in airline operations or complex aircraft?
Precisely. It reflects the heightened safety expectations and the demand for the absolute highest reliability in commercial passenger transport and complex aircraft operations. The risk profile demands a more stringent approach.
Okay, that makes sense. A higher bar for higher risk flying. So, finally, let's tie all this together. We need to look at AMC 145.A.42, subsection B, clause 1. This covers the actual acceptance of components for installation. This is where the rubber meets the road, right?
Exactly. This outlines the practical steps, the procedures an organization must have in place to make sure every component, standard part, and all material coming in is actually airworthy before it gets anywhere near an aircraft. It's the gatekeeper process. Clause A sets the objective. The procedures should have the objective of ensuring that the components, standard parts, and materials are in satisfactory condition and meet the organization's requirements. And these procedures must be based on incoming inspections that include two key things. 1, physical inspection of the components, standard parts, and materials. And 2, review of the accompanying documentation and data, which should be acceptable in accordance with 145.A.42A. So it's a two-part check. Physically inspect the item and meticulously check all the paperwork against the requirements we've just discussed.
Hands-on check and paperwork check, both essential.
Both essential. And Clause B adds another important layer. For the acceptance from suppliers, the above procedures should include supplier evaluation procedures. It's not enough to just check the part when it arrives. You also need procedures to evaluate your suppliers. Are they reliable? Do they have good quality systems? Can you trust what they send you? So before you even start ordering regularly, you'd likely audit or review a new supplier's processes.
Oh, that's really interesting. So you're not just checking the product, you're checking the source too. That adds a whole other level of confidence in the supply chain.
It does. It's about ensuring quality consistently right from the source.
Okay, and to wrap this up, there's guidance material again, GM1 145.A.42B1, giving more detail on that incoming physical inspection.
Yes, this provides the real practical hands-on checks. It assures you catch potential problems right at the door, reinforcing all those rules about unsalvageable items we talked about earlier. Clause A just reiterates the purpose. To ensure that components, standard parts, and materials are in satisfactory condition, the organization should perform incoming physical inspections. It's that first line of defense.
A mandatory first step.
Mandatory. And Clause B emphasizes the timing. The incoming physical inspection should be performed before the component is installed on the aircraft. It has to happen proactively. Catch issues before they get integrated. A mechanic can't just grab it off the shelf and fit it. It needs this check first.
Right, prevention is key.
Definitely. Now, Clause T gives a list of typical checks. It says the list isn't exhaustive, but includes things like 1. Verify the general condition and their packaging in relation to damages, so look for obvious damage. 2. Verify that the shelf life has not expired. Check those dates. 3. Verify that items are received in the appropriate package, like correct anti-static bags for sensitive devices or proper ATA 300 containers. And 4. Verify that the component has all plugs and caps appropriately installed to prevent contamination or damage. It even specifically warns about using tape over connections or openings because the sticky residue can cause problems later. It shows the level of detail needed.
Wow, yeah. Down to checking for sticky tape residue. That really emphasizes the thoroughness required. Checking packaging, dates, physical condition, protection.
It's all part of ensuring integrity. And lastly, for items coming in batches, Clause D clarifies the requirements. Things like fasteners, rivets, bolts. They should come in a package that states the spec, the part number, the batch number, and the quantity. And the documentation that comes with them must also have all that information, plus the manufacturing source. Crucially, if the material is acquired from different batches, acceptance documentation for each batch should be provided. You need separate verification for each individual batch.
So batch control is vital for those smaller items. You need to be able to trace every single batch.
Exactly. It's all about that unbroken chain of traceability and conformity.
So putting it all together, that incoming physical inspection is the practical frontline check. It's where you catch damage, expired items, wrong packaging, missing caps. Making sure the part you're about to accept into stores, let alone install, is exactly what it's supposed to be, and in the right condition.
That's it. It's the final quality gate before it enters your system.
Well, that was incredibly thorough. We've covered everything from the hard no of unsalvageable components, through standard parts materials, right up to the detailed checks needed during incoming inspection under 145.0.42. It really paints a picture of just how meticulous aviation maintenance has to be.
It really does. And understanding these definitions, these procedures for accepting components, it's not just about ticking regulatory boxes. It's truly fundamental to the safety and reliability of every single aircraft flying. And it does raise a question for you, the listener. Reflecting on all this, how might these very stringent requirements perhaps make you reconsider or refine your own approach to verifying every single item that enters your supply chain?
That's a great point to ponder. In our next deep dive, we will continue exploring 145.A.42 components, building on these crucial foundations we've laid today.
And don't forget to follow us on social media. Just search for Phoenix Way Academy.
Thanks for listening. Stay safe and stay informed.
Stay safe.